Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi again, everyone. So let's continue the discussion on hydraulic system. And in this example, I will show you how we design a simple mechanical clamper where we want to clamp a certain object, forcing it to remain stationary. So the principle behind this design will be the Pascal's law and the mechanical lever. So without further ado, let's look at the solution. Alright, so let's first draw the system. This is a system consisting of a mechanical lever, and we have a piston here, the first piston connected to the second piston. So this is the placeholder. That's the object we want to ensure being placed at the location. So let's label this piston 1 and piston 2, and then we have the lever, okay, X and Y. That's the distance. X is the distance from the input force to the pivot, Y from the pivot to the output force of the lever, and we know X plus Y is equals to 750 millimeter. That was given in the question. So we have D1 and D2. So D1 is the design parameter, and D2 is also another design parameter, which is the diameter of the piston, and we can choose any value as long as it is less than 100 millimeter for both 1 and 2. So I'm labeling the force, the clamping force, FC here, and based from the question, we want it to be in between 2000 Newton and 3000 Newton, and the input force, let's label it as Fu, so it should be less than 100 Newton. Okay, so this is the question. So basically we need to choose values. So design implies finding the values for the unknown parameters, so the X, Y, which are the parameters for the lever, and then D1 and D2, which are the diameters of the pistons. So we ignore gravity in this case. Anyway, so from the lever we know that the we know the lever relationship is, you can refer to your notes, figure 3.6b. So Fu times X is equals to the output force times Y. That is the relationship from figure 3.6. So I'm labeling F1, that's the output force. So Fux is equals to F1y. So we can rearrange, in this case I've rearranged it to be F1. That's the output force of the lever, but it becomes the input force to the piston or the hydraulic system. So F1 is equals to Fu times X divided by Y. Okay, that's from the lever relationship. So let's just assume that we want to exert 100 Newton of force at the input. So I'm just replacing Fu equals to 100. So then f1 is equals to 100x over y. This is the first equation that we know. We also know that x plus y cannot be more than 750 millimeter. That could be some restriction in the size of the lever. So that's the second equation. And then we can apply Pascal's law for the hydraulic system. And Pascal's law states that the pressure in the fluid is equal. So pressure is equal to force divided by the area. So F1 divided by A1. A1 is the area of the piston 1. Since the pressure is equal throughout the system, that means F1 over A1 is equals to Fc over A2 is equals to the pressure of the oil. So we know that we want Fc to be in between 2000 and 3000. So let's just choose a value for the clamping force. So Fc 2500 Newton. So if we substitute the value, and A2 we can calculate, a piston is a circle, so it's just the diameter divided by 2 squared. That's the area of the circle by r squared. So Fc over A2 is equals to F1 over A1, and A1 is just pi over D1 over 2 squared. Okay. So let's simplify the equation. You can see that there are constant terms cancelling out, and then F1, which is the input force to the piston to the hydraulic system, is equals to D1 over D2 squared times 2500 Newton. Okay, that's the output force. So that's equation 3. So we can substitute the relationship that we know from 1 into equation 3, where F1 is equals to 100x over y. So let's replace F1 equals to 100 over x over y into equation 3. So we can simplify it further. And we can also replace y by using equation 2, where y is equal to 750 minus x. So this is the main relationship that describes this problem. So there are three design parameters that you can play around with: the diameter of the pistons and the x, the distance from the input force to the pivot of the lever. So here I'm just choosing a reasonable value, I think. Okay, yeah, just a starting value. So if you choose x equals to 500, remember x should be bigger than y in order for you to amplify the force, output force of the lever. So I'm using x 500, meaning y will be 250. And I'm choosing the diameter of the piston 1 to be 10 millimeter. So let's just solve for the diameter of piston 2. If you do that, then you will get D2 is equals to 35 millimeter. Alright, just very simple design problem. So you can test these values: x equals to 500 millimeter, D1 equals to 10 millimeter, and D2 35 millimeter. And also that means y is equals to 250 millimeter. You can test whether that it's actually giving you 2500 Newton. So that's basically the solution to the problem. So there are many other choices of x and therefore y, and also d1 and d2. So the idea is just x should be bigger than y and d1 should be smaller than d2, so that some amplification will happen two times, fu to f1, and then from f1 to fc. Okay, so thank you for listening, thank you for watching. See you again in class. Bye bye.